We are recording. Here we go. And good afternoon, everyone, from Lincoln, Nebraska. I'm Ben Bohall with the Nebraska Forest Service, and this is Through the Thicket. We're live here every Thursday at 12:30 Central Time, and we're always talking about trees and plants. And, well, it's October 1st. It's a new month and pretty much prime time for planting. I'm here with Graham Herbst. He's our community forester for Eastern Nebraska, and we're welcoming back Chrissy Land. She's our community forester for Western Nebraska. How's it going, guys?
Good, Ben. Thanks.
So we're talking fall colors. Seems like the perfect time of year to be jumping into this.
Yeah, it is. I know Chrissy's starting to see a bit more fall color out west than we are over here a bit, and that's very normal. We sort of ease into fall a little bit later. What are you seeing out there, Chrissy?
Yeah, here in the last week, it's actually been kind of fun driving around and seeing, I think I usually notice one of the first ones is the ash trees. Ash start to turn their brilliant yellow. And then the other one that I started realizing was the hackberries. And it's kind of cool because like right now they're still green for the most part, but just the outside edge of them, it's almost frosted yellow because only a handful of leaves are beginning to turn yellow. And so it's kind of this cool like multicolor tree right now that's has some pretty cool interest to it.
Yeah, neat. That is cool. The way there's sort of a pattern to how fall color occurs on some trees that's different than others, aside from just the color variation itself.
It was neat too. I guess I drive across the North Platte River every day, and there's a spot kind of along the highway that's a bunch of cattails. And I think it's interesting how the cattails can turn kind of their like amber, orange, red color, and then they just turn brown. And they've already turned brown. But then like the cottonwoods on the river, where they're exposed to that cool, moisture off of the river and everything, they're just barely starting to turn. And like probably only like 10% yellow. And so I definitely think that when those trees go into full fall color, it's one of my favorite views.
Yeah, and it's also nice because even with the grasses that we don't think of as having fall color per se, but we get this, the sun is lower in the sky and shining behind plants more.
Right.
And so we get a lot of that brilliance of the interplay of sunlight coming through the grassy seed heads or the fall color or what have you.
Yeah,
I love to. Go ahead.
I love to pair grasses like the little blue stem that turns red in the fall, and then it's the dwarf rabbit, and not rabbit. It's got the big fuzzy seed heads on it.
Oh yeah, is that a
Pennisetum?
Pennisetum.
There's it's a dwarf variety of it. I can never remember the name of it, but to pair those two with like some asters and some fall mums, I think that is a really great showcase in the garden.
Yeah, maybe some Aronia. We'll talk about that one in a little bit.
Yes.
That'd be nice with that. This picture down here in the bottom right reminds me I should be paying closer attention to which trees have fall color start in between in the interveinal tissue. We see here the veins of the leaf are staying green longer than the tissue in between the veins. And
right.
I know I've noticed that on trees before, but I don't know if I've noticed a pattern between, maples do it this way and oaks do it a different way or anything along those lines.
I mean, if we think about, the trees like pulling that, those nutrients out of that and back into the veins, and the veins are kind of the last thing to pull it down into the woody tissue.
Right.
It makes sense why it's in between the veins, but I love that picture. I think it's so cool.
Yeah, and this could be a very short window of time. Like this picture might be really capturing something that's happening more or less right then that day.
Right.
So let's just get right into it, because I do have a slide here that puts this whole process in an evolutionary timeline, right? So if we go back 500 million years on this planet, life was really only in the oceans. We only had aquatic life at this point in the planet's history. As we started to get algae and things like that making their way and adapting to, you know, sort of transitional areas where maybe the tide came in and out, or evaporation occurred, and they sort of adapted to that dry spell, then they were able to adapt to being on land all the time. And when we get to about 385 million years ago is when we have the first plant that was giving secondary growth. So this is kind of the beginning of wood, right? Where it's a plant that's sort of growing another plant on the outside of it every year. If you want to, I mean, that's not actually what's going on, but it sort of seems
putting on a coat of new growth every year.
Yeah, yeah. And so you have this tissue that you can hold on to and keep the energy that you've made instead of constantly dying back to the ground for one reason or another. And then, you know, a few million years after that, we had the first roots, seeds, and leaves. So in this case, we're still mostly talking about conifers, things with needles, or, you know, large ferns and things like that.
Some scales and stuff. Okay.
Yeah, yeah. So it wasn't until about 130 million years ago that we even started to get plants with flowers. So this is still very far back. But what trees represent on this timeline is the first point in Earth's history where plants really push into marginal areas. They're not staying in the warm, humid parts of the planet and right by water sources, and really starting to establish more widespread all over the place. And so they adapted this ability to be in colder climates through this leaf drop, right? We had deciduous trees that said, I'm not going to have these needles that stay around all the time, because when I try to grow where it's cold, it takes a lot of energy and moisture for me to keep those needles alive, which is part of why we're always on the show telling you to keep those pines and spruce and stuff watered if you can over the winter, because they do get dried out sometimes.
Right.
So then once trees developed the ability to have broad leaves that were intended to be dropped every year, that's obviously where the fall color kind of comes into the mix of all that. And it's pretty ingenious, because it takes a lot of energy to grow a leaf in order to just drop it every year and have to grow another one. But the fall color is partially happening because of the plant taking energy back out of the leaf, right, Chrissy? How would you describe it?
Yeah, I mean, it's, you know, we look at day length, it's a big equation of multiple things that go into play as far as, you know, and I know that you are going to cover day length here soon, but, you know, the differences of the angle of the sun, how much sun we get every day, and then the fluctuations of our temperatures, you know, due to day length and the angle of the sun. And so all of those things start to trigger this chemical process where that tree is actually taking the green pigment out of the leaf and pulling it back into the woody tissue and going through a process that we call senescing. And basically it's shutting itself down properly so it can pull those nutrients out of the leaf, put it into the woody tissue to be able to store it and utilize it over winter while its metabolism is slower, not stopped, but it's sort of going into hibernation. And so it goes through this chemical process. So a lot of things have to kind of line up, but I love this video that you are about to show us. So let's check it out.
Yeah, certainly. So this is a time-lapse video that we'll link to in the description. It's beautifully done, and it's showing how right now the sun is coming from about the middle of the screen and staying fairly low in the sky. We're looking east, I can tell from the way that the sun moves. So trees are adapted to tolerate these cold winter temperatures year to year and persist. And their ability to make wood is what allows that to happen. When we talk about tender perennials and annuals, they may have root systems that are hardy in the wintertime, but what's growing above ground can't persist that way. So trees fill a unique niche in terms of being able to have tops that persist year to year in conditions that otherwise wouldn't be very conducive for plant life.
Right. And you talk about, how much energy a tree, like an evergreen, like a pine or something, spends on keeping those needles, full of moisture and keep them from drying out in the winter wind. And you think about, well, how much energy does it take? Like, let's do a comparison between keeping the needles, but you got to think about the area, the total area of the leaf. The needles don't have as much area as like a broadleaf. And so to be able to keep a broadleaf through the winter, that's a lot of energy that tree has to spend. And so maybe it is, a genetic thing, or a genetic thing, of course, but like an evolutionary thing that realized, I'm making trees think now, that, that's too much energy, and it's less energy to actually shut that down and maintain that focus on the leaves or the twigs, and keeping the twigs from drying out and being able to store that energy back into them and then reuse it the next spring.
Yeah, it's like the foliage is the front line defense, but it's sort of expendable in that way, and thrifty in terms of capturing as much energy as possible back out of those leaves before allowing them to desiccate and dry and fall off. Another really important fact here is that foliage being grown in large quantities and being deposited on the floor is also building forest soils in a much more rapid rate than we would see otherwise.
Yeah, and that's a great point, is that the trees are improving the environment that they're growing in by recycling, what they can't pull out of the leaves back into the root system, that then other organisms in the food chain are going to break down back into a form that the trees can then take back up and use again. And so it's, they're not giving up so much as if we would think. But the other thing too that we have to remember is that there is also green pigment in the bark and so when we see species that have, some really thin bark, and, if they're just a little bit green tinted, that is still photosynthesizing. It's not photosynthesizing in a way that we would, think about leaves photosynthesizing. It's still photosynthesizing. It's still green chlorophyll pigment and going through that process. And so it's not only are the leaves producing oxygen, but the twigs and the trunk is too.
Yeah. And lots of times, like the sort of plants that we see that in, when I think of crabapple, I think of maple a little bit. I think of dogwoods. There are also plants that are also adapted to colder climates and shorter growing seasons. And so it's more imperative that they have maybe a secondary strategy for photosynthesis that doesn't rely so much on the foliage itself.
Right.
So cool. So then obviously chlorophyll is the pigment that gives leaves their green color. Green is the spectrum of light that's reflected back to our eyes and not being utilized as much in the photosynthetic process.
Right.
As they start to dry out, then we see some pigments that are still present in the leaf, like the carotenoids here in the middle, the yellows and the orange tones. Mm-hmm. Those are in the leaf already all the time, but they're not visible to us when chlorophyll is so abundant in the leaf. And then you had some interesting information about the reds.
Yeah. So as you asked me at the beginning, what am I seeing as far as fall color right now? Everything I said was yellow. Mm-hmm. Usually we see the yellows first because you get the yellows and the oranges by having the green, the chlorophyll, being pulled out of a leaf from by the tree. And this is this whole chemical process. So the green comes out, which allows the yellow and the orange to show, which is why we see them first. Yeah. And later on, as that process goes on, some species like red oak or some of our maples, let's see, what was the oak? Shumard oak, is that what you had, I think? Yeah. Black gum, a few of those that are really brilliant red in the fall, they have a higher concentration of anthocyanins, if I say
Mm-hmm.
correctly.
Yeah.
And it's actually the chemical process of those, like they're not present in the leaf year round. But instead, like during this chemical process, they are actually produced by the plant. And so
Right.
that's where you start to see that function. And, you know, it's kind of cool because the yellow is always there, the red is not always there, but some species produce more red chemicals than others. And, you know, some species like aspen or ash or maybe even cottonwood that are pretty much all yellow, you know, they're producing very little amounts of the red chemical. And so I think it makes sense, you know, as the green goes away, the yellow and the orange show. And then the process of going through that chemical change is when the red is built and made. But the biggest thing about all of it is that it sort of is like a recipe for beauty instead of a recipe for disaster. It's a recipe for beauty. You know, the important parts is that we have to have cool nights and warm days that are dry. And so there's really wet weather in the fall, or say Mother Nature throws a wicked trick and gives us, you know, temperature extremes where we go from 100-degree days down into the teens, or if not the single digits. And if you think about it, when you cut a branch off of a tree, those leaves just turn brown. They just go straight to brown. There's no color change in those leaves. They go straight to brown. And so if Mother Nature creates an event that causes that damage, that tissue to just die, it's going to go straight to brown. And so that's when we can kind of see, you know, and a lot of times those twigs don't develop, you know, that seal on the leaf scar to be able to push that leaf off. And so you'll start to see some damage into the tips of the branches and everything. And so that's where it's important that, you know, fall, we were lucky, I guess, here in Scotts Bluff more so, and I haven't seen a lot up further north in the Panhandle where they did get like 7 inches of snow a couple weeks ago. We got freezing rain, and then we were followed by some warm days, cool nights, and then dried out again. And so now we're starting to see that really pretty fall color starting to pop on the river and everywhere else. And so, but I wouldn't be surprised if some of our, you know, more marginal species, like some of the maples that are in the North Panhandle, that might see some tip dieback from that early freeze, that early extreme temperature change. And so, and those are all things that it's just cumulative stress that it's good to take note of. That way, if our tree starts to look bad, we can kind of add that to the equation of like, what's going on.
Yeah. So whether we're talking about the flowers that a tree produces or this fall color, it's really ultimate, you know, the beauty is just an offshoot. It's secondary to the clever utility of why that plant evolved that in the first place. So it just happens to be attractive to see fall color or to see flowers on a tree. But in both cases, it's indicating a much more complicated process that has real meaning and utility to the biological processes of the tree.
Right.
So what we're talking about today is really broadly called phenology, where we're making observations about when different processes in a plant's life cycle occur, whether we're talking about the breaking and emerging of the leaf buds in the spring, or when it blooms, fall color. All these things we can use to time with other organisms that coincide that way. And oftentimes, as you'll see in the legend here in the bottom right, GDD stands for growing degree days. So we can track the cumulative temperature change over time and see very direct correlations between, as we talked about with emerald ash borer, the black locusts are typically blooming at the same time that adult EAB beetles emerge from trees, because they have similar growing degree day requirements for that temperature change. So we can use this to forecast when allergies are going to be bad, when fall color might start to occur throughout the country, lots of other things like that that have some use.
Right. Yeah.
So this,
There's a lot of science in tracking timing of, and like you said, I mean, it's everything has a relationship, you know, whether it might be, like you said, the pest and the what it's going to be attacking, you know, are those degree temperature days lining up for a really bad year for something. And that's why some years, you know, like this year we had sort of a crazy moth problem here in western Nebraska. And, you know, the conversation was, you know, just, it was a matter of everything just lined up for that population to just flourish. And so, you know, some years you have insects that are really bad, some years that are not. And a lot of it has to do with, like you were talking about, those degree days, and not they line up with the sort of the predator and the prey, kind of.
right.
But
and there's nothing in springtime that could help us forecast when fall color is going to start, because it's still so much about the immediate climate, you know, the days before and what's been happening lately. So we need to have warm days and cool nights for that fall color to set in, instead of just plunging into cold temperatures 24 hours a day really quickly.
Right.
But you were mentioning something else that's a factor with that as well, on when and how fall color develops. In terms of precipitation.
Right. And that's, if you think about precipitation, that changes how much humidity or how much dew is in the air, which is going to change the temperature. And so if there's a lot of moisture, you know, we're not going to have as much of an extreme difference between the cold and the warm. It's going to be a little bit more gradual. And so it's, you know, talks about how there's not going to be as brilliant of a fall showy color if there's a lot of moisture in the fall. And so when we have dry conditions, really cool nights, and really warm days, then that's when the recipe gets just right for beautiful fall color.
Right. So you need the dry conditions to sort of initiate the leaf senescence, and you need the warm days to keep those leaves on the tree to actually show the fall color and let that whole process occur.
Right.
So neat. So then we just, I figured we cover a handful. I mean, there's an exhaustive list of plants with beautiful fall color. So these are just some highlights. Part of the reason I wanted to put witch hazel in here, it's not a tree, it is, you know, more of a small shrub, is because we not only have this brilliant orange and red in the fall color when it gets the chance to show it to us, but we also have a plant that blooms in the wintertime. And not only blooms, but fragrantly so, right, Chrissy?
Yes, I love it. It's strange because it's like, I recall there's a few shrubs on the north side of Plant Sciences Hall on East Campus. And, you know, one morning I was just like walking by, headed to class, and it was just like, kind of smacked me with that beautiful smell. And it was like, oh man, I need to go investigate and find out where that's coming from. And found a few witch hazels that had these cool spider looking flowers all over it with no leaves. And that's what I thought was cool, is that it blooms before, like you said, in the winter, before it puts the leaves on. So first late winter, like very early spring, one of the first things that we see bloom.
Right. And there's a couple species that some of them bloom really late fall and others really late winter, and obviously wind pollinated plants, right? They're not relying on insects to move their pollen around. Aronia is a great one for the whole state. I don't think there's anywhere that we can't do this plant successfully in the landscape. Iowa is the largest producer of Aronia fruit in the country, so it's well adapted to our Great Plains climate and the soils. The fruit itself it's edible. It's not something that I pull right off the bush and eat, but it does have. There are a lot of ways that we can utilize the fruits. But the fall color is kind of interesting because we get this mixture of green leaves with those with the fall color started already.
Yeah.
I can't make sense of why that happens on a plant.
The other one that's a lot like that, that I like is that currant. I think currant can have a really pretty fall color where it's sort of multiple colors like that, where you kind of get some burgundies, some yellows, some oranges, some reds, some greens. And it's kind of, those are my favorite, is the ones that have all the colors. They're not just one color, they have all the colors.
Right, right. The reds that people talk about a lot, some of the oaks, I don't see red oak, the red types of oak, having as reliable a fall color as some other types of trees. But boy, when they show it, it is pretty spectacular. And you'll notice that the red even goes into the leaf petiole itself, and you know, it's just red all the way back to the twig. Black gum, Nyssa sylvatica. This is more native to the lower Missouri River corridor, so we don't even see a lot of black gum once you get north of maybe Nebraska City or so. So it's not one that we can pull off on much of the state because it is a little marginally hardy. But I put it in here because the fall color varies so much from one tree to another. If you buy 3 black gums and tuck them in an area where they have the space to grow, you'll see different fall color on all 3 of the trees, somewhere in that spectrum of orange to red, and that's kind of a unique feature.
Mm-hmm.
White ash.
I will love them as long as I can.
Yeah, yeah.
This is fun. It's, you know, I've been working on a few inventories with some communities, and we are out, and of course most commonly we have green ash and white ash, and you know, they tell me, they're like, oh, this tree is beautiful in the fall, it's like kind of turns red and orange and yellow, and I'm like, it's an autumn purple ash and it's a white ash. And so I think they're a gorgeous tree. You know, I just said I love the trees that have, or I love the fall plants that have all the colors. And this really is one of them. I mean, there's sometimes where it's kind of green on the inside, if you're up underneath the tree and kind of looking up into the branching structure, you know, some green will stay on the inside. It's almost like the sun just starts to change the color of this tree gradually from the outside in. And so it's like the outside turns dark, and then you get into like this inner layer that starts turning orange and yellow. And so it's got the red on the outside, the orange and yellow, and then the green on the inside. And so I think they're showstoppers. They really are. It's a bummer that they are a white ash, and we will probably have to say goodbye to many of them thanks to emerald ash borer. But like I said, I will love them for as long as I can.
Yeah, we can appreciate them while we have them, and I'm sure that they'll be able to select for this trait in new hybrids, you know, 20, 30, 40 years from now, when we can potentially plant ash species again.
And there is that beautiful pennisetum, that grass down there at the bottom. This is not the dwarf variety. It's the full size, and then I think it's some Carl Forster behind it. And so, I mean, and that's the thing is, you know, fall is really when the grasses are showstoppers.
Yeah.
They really shine in the fall. And so having, you know, that blonde color backlit, or, well, not backlit, but backgrounded by a contrasting green, and mix it in with some beautiful fall color foliage with some trees and shrubs, and got a beautiful fall landscape.
Yeah. And you hinted at this a little bit earlier, but based on our slide earlier about how fall color develops and the different pigments that are at play, I agree with you. It seems like what's happening is that those red pigments are being initiated to be produced on the outside of the canopy first, where it's warmer and they dry out faster than the interior canopy leaves. And so it gives you that effect where it's almost like a lantern that's lit from within.
Yeah, it's really, and you know, Graham, now that you say that, that's perfect, because it is. It's, you know, that outer layer is the most exposed to the fluctuation extremes. You know, in the nights, it's exposed to the cool air that surrounds the tree first. In the day, it's exposed to the warm, you know, the warm air that then heats it back up, and the sun is drying it out and everything. And so it makes sense why the science is working with this tree. So they're fun.
They are. Now,
maybe that's what's happening with, that has to be what's happening with those hackberries that I've been seeing.
Yeah.
The insides of them still green and the outside starting to turn yellow. They're starting to shade from the outside in.
Yeah, it's a heat and temperature difference going on there. Now, I am a fan. I really like to advocate for trees with yellow fall color if you're looking for fall color, because it's sort of underappreciated. Everybody gets so caught up in the reds and the oranges, and they are fantastic. And so my observation was that when we plant trees as individuals, the oranges and the reds stand out more. But if we're in a forest, the yellows are really more spectacular because you have a darker, forested environment for that color to really pop out of.
There's way more contrast. You think about the number of people that travel every fall just to go see like the aspens in fall color. And that's exactly like the forested atmosphere where you have the dark evergreens, usually a spruce or pine in the background, and that yellow is just like this shining beacon of beauty.
Yeah. If you have a single tree with a lot of sky around it, obviously orange and red is going to stand out more. It's going to draw your eye in a way that yellow doesn't. But you're right, when you've got a forest with a bunch of Douglas fir and aspen or something like that, boy, that yellow is really going to stand out more.
Right.
So we have tulip poplar here with its very characteristic sort of duckfoot leaf to it, symmetrical but even lobed without a central lobe in the middle, and those kind of buttery yellows that you get out of this tree, as well as the hickories, honey locust, things like that.
Coffee tree.
Yeah.
Our favorite yellow one.
Definitely. And coffee tree is a great one too, because it has those persistent pods that are dark, and they contrast with the yellow really nicely also.
Right.
Now, fall is also fantastic because we can plant things, and all those people that like tomatoes and cucumbers are done planting for the year, and we get another planting season to ourselves.
Yes.
You've been doing a bit of that lately, haven't you?
Oh boy, yes. We have been planting. We recently we're in the final stages of wrapping up a fall grant that we partner with the Nebraska Statewide Arboretum, and for they have kind of the grant source and oversee all of it, and I get to work with the applicants and the communities and do a lot of technical assist on training and proper planting and explaining the nursery practices of developing containerized trees and what sort of challenges that creates for us at the time of planting. But the biggest thing is selling fall planting. And I explain to people that in the fall the ground is warm, but the air is starting to cool down. And so as we've been talking about, the tree is beginning this process of pulling, that energy out of the leaves and putting it into the woody tissue. And so if the ground is still warm and there's no open leaf surface left on the tree, then that tree is not, using energy in the canopy in the fall, and it can put that energy into developing a root system before the ground freezes. And so for Western Nebraska, we try to make sure that we have trees planted absolutely no later than October 15th. And I think for Eastern Nebraska, maybe it's like later October is.
Yeah, Halloween, I like
Halloween,
planting dormant trees. If they've completely dropped leaves, that's usually still okay. The biggest challenge is just being sure that you can not have too chunky of a backfill going in. You want to be sure that the ground's not so cold and hard that you can't break up big clods and properly backfill the tree.
Right.
And then of course you need to be able to have some way to water it in a bit, if you're going to plant it, in a really cold time of year.
Absolutely. And that's That's like the number one reason why a lot of people don't want to plant in the fall, and they say to plant in the spring instead, because in the spring we usually have a lot more natural moisture. We're turning our sprinkler systems back on. And so, they're not having to lug a bucket or a hose or a truck, with a water tank on it out to that tree. And really, what I tell these grant applicants is that after we plant the trees in the fall is make sure that you check them 3 times a week for at least 1 to 2 weeks, and then back it off to 2 times a week, and then at least once a week until the ground really freezes hard in like late November, early December, even sometimes mid-December. And then emphasizing that, especially for these evergreens, it kind of goes both ways. A lot of people say you should really plant evergreens in the spring, just because in the winter, if they don't have water, they are constantly sort of sweating out of their needles. And if there's not water in the ground for them to replace what they sweat out or what they evaporate, then they can ultimately winter desiccate. They can dry out. And so, even in January, the last couple of years, we've had warmer temperatures with less winter moisture. And so, on days that it's like more than 50 degrees and that top, couple inches of the soil thaw out, go out with a 5-gallon bucket and pour some water on those young trees, because it will make a huge difference. Because typically in the fall, we're shutting off our sprinkler systems and we're blowing them out. And then it's like, okay, like you're on your own for the next 5 months. Good luck. We'll see you in the spring. But really, when we plant in the fall, we should be making sure that we are routinely keeping that ground moist, because again, that ground is still warm, usually warm enough for root growth up until late November, if not beginning of December.
Yeah, and with those warmer temperatures that are going to cool off again, that increases the transpiration, the water loss of the tree when it's warmer. And if you haven't had a lot of snow falling and staying and covering the ground and buffering that soil temperature, or falling and melting and falling and melting and putting moisture back in the soil, then those warm-ups that are going to cool back down again can be stressful. Right.
Yeah. And even for our deciduous trees that are dropping their leaves, they still have to keep their leaf buds and their twig tips full of moisture. Mm-hmm. And winter winds will dry them out. And so if like Grandma's saying, like if there's not enough natural moisture happening, and just kind of working with that, making sure that those trees are still getting water throughout the winter. But yeah, I planted probably 13 trees last fall, like October 27th. And I think I lost 4 of them. And it was only because they were too big for their own good. They were some trees that I happened upon, and they were very pot bound. They'd been in the container too long. And so I don't blame it on the winter as for why I lost them. I blame it on other reasons, but the rest of them are doing great. They're ready after being in the ground for a full season. There's many of them I'm going to be taking off all of my supports. They are well rooted in, and they're doing great. So
fantastic. Ben, you got anything for us from the chat?
No, nothing new, it looks like. And so, we'll remind everyone, if you do have any questions, feel free to leave them in the chat box. Oh, and it looks like we're wrapping things up. I know you guys covered a lot of ground. It was very interesting. A lot of things I personally didn't know, which I think are good to learn about going into this season. So if you're out there and you're watching the episode and it's after we've been streaming live, you can always send your questions to trees@unl.edu. So do we know what we're covering next week, guys?
We haven't decided yet.
Okay.
So we're not.
If anybody has a request, shoot it our way, and we'll talk about it.
That is a great idea. You can also you can leave it in the comment box, or you can send it to trees@unl.edu. It's always great to hear from everybody who's been watching. They give us some great ideas for things to cover. Graham, Chrissy, thanks again so much. I hope you guys have a good rest of your week.
Yeah, you too, Ben. Thank you.
So enjoy that fall color while it's here.
Absolutely.
everyone.
See you guys.
Bye.